Hello and welcome again. The purpose of this video is to show you how to transform a byte, which is going to be represented by, in this way, xy, where every x and y here are in hexadecimal form. X is the first 4 bits of the byte and the y is the last 4 bits of the byte. And this transformation is going to be done using the X box of the AES, which is this table here. That's a table that we're going to use for the byte transformation. Now, of course, and then this is going to have to be applied for all the bytes that are in the 128-bit block, which are 16 of them. So this is just an example of only one byte. So let's go into the example. So let's look at the first example. So the first example is that byte that you see here. So this is my byte. So of course it's a bit, zeros and ones. So the numbers here on top denote the positions, and these are the entries in the byte here. So the first thing you're gonna do is you have to represent that byte into the x and the y. And remember what I said is the x and the first 4 bits. So I'm gonna take the first 4, which are these ones here, and I'm gonna take the last 4 also. I'm gonna represent those 4 bytes individually using the table that you see here that I have on the left. So using this table here. And basically what the table is telling you is what is the binary, for example, this row here, what is the binary representation of 0 and the binary hexadecimal representation of 0. The second row is for the number 1, 2, and so on and so forth until you get to the number which is right here, the last one, that is 15. All right, so what happens here is the following thing. So we're gonna look at these things that are here. So the first 4 bits of my byte. Remember, you take the byte and you divide it in 2 halves. The first half, the left hand side, and the right hand side. We'll look at the left hand side first. So I'll have to look at 1011 in here in this table and see what hexadecimal is that represented. So 1011. Let's look at here. 1011. 1011 is right here. Let me mark that down with a color. So I'm gonna use for that purple 1011. That's B. So it's this part here. This is my the first 4 bits, which you see here, 1011. That's represented by B in hexadecimal. So I'm gonna write down B here. So that would be B. Now the second half, which is the last 4 bits, is 0110. I do exactly the same thing. I look at the table and see where that one is. So that one is again, it is 0110. 0110. That is right here. So I'm gonna mark that down with color 0110. That is 6 in hexadecimal. So I'm gonna write down 6 over here. So that's 6. So what my byte, that byte that I have at the beginning, is represented by B6 in hexadecimal. Now, with that representation, once you have that representation, again, you start with the byte and you represent it like this. The first half is 4 bits, and then that's gonna be corresponding to some hexadecimal digit, and the second half also to some hexadecimal digit, and then we get this one. Now, with this information, what we do is we're gonna look at this in the table. So B is gonna be the rows, and 6 is gonna be the columns. So let's look at that. So in here in the table, I have to look at B first. So B, the first number you look at here in this column right here. So B. So that's B there. I'm gonna mark that down. This B here. Let me use the color. I'm gonna mark it, that row B. That's the corresponding to the first 4 bytes of my array, which is B there in that case. So that corresponds to this B here, or this one. And then I look at the column 6, and then I see where they intersect. What is the intersection of those? So I'm gonna look at the column 6. Here are the columns. So this is 6 over here. I'm gonna mark that down with color. So 6. Let's go and do here. And as you can see there, they intersect. What they have in common is 4E. So what that means is my byte, which is represented by B6, is being transformed into the byte represented by 4E. So I'm going to write that down. My X box, what it's actually doing here is taking this byte, the S box, and it's transforming that into another byte. And this byte now, this is another byte. It is a 4E. And there's 4E in hexadecimal. And why is it 4E? Because that's the intersection of the column and the row. Let me go back again over there. So that 4E that you see here in the middle is the intersection of the column B with the row B and the column 6. Now, if I want to know what the byte of this one is representing, the only thing I have to do is I look again here on my table and see what is the binary representation of this 4 in hexadecimal. So that 4 over there, and I'm going to use another color here. Let's say, for example, we use yellow. And so 4 will be this part over here. This will be 4. Let me see. 4. So that will be 0, 1, 0, 0. So now if I have to write down the first 4 bits of my byte, this will be equal to 0, 1, 0, 0. That's 4. And then I do the same for E. So I look at E and see where E is in here. So E is right here. And so I'm going to mark that down with color. Let's say I use yellow again. So it's going to be E. And then the bits that I have there is 1, 1, 1, 0. So I'm going to write that down. And then it's going to be 1, 1, 1, and 0. So this is the byte transformation. I started with this byte that you see here, this byte, and the X box is transforming that byte into this other byte that is right here. So that was one example. Let's see another example just to emphasize what we're doing. So let's look at some other. So let's say in this case, we have this byte here. We have this byte. So 8 positions here, and I have my bytes there in the middle. So again, I do exactly the same thing. So what I do is I'm going to mark down the first 4 bits of my byte. That's the first 4, and then the last 4. And I'm going to represent them in hexadecimal. So what I have to do is I have to look at where in my table is 1, 1, 0, 0. So let's see that. 1, 1, 0, 0. 1, 1, 0, 0 is right here. I'm going to mark that down with some color. So 1, 1, 0, 0. And that is represented by C, by the hexadecimal digit C. So that's going to be a C. The first 4 bits are represented by C. The last 4 bits, which are this guys over here, 0, 1, 0, 1, I have to go look again at the table and see what hexadecimal is that representing. 0, 1, 0, 1. That is going to be over here. That is number 5. So let me mark that down again with some color. So that's going to be the number 5. So those 4 bits are, in this case, the number 5. So I'm going to write that down here. So that's going to be the number 5. So what I have, again, same thing as before. My 1 byte is represented by C5 and hexadecimal. So what I do is, of course, I'm going to look at my X box and see what is the byte that is being transformed to. Let me correct that and put a 5 there. All right, so I have to look at C5. So C for the row and 5 for the column. So let's go all the way back to the table. So I'm gonna use another color here. So let's say, for example, now I'm gonna use a purple here. Is C5. So I'm gonna mark the C. So this is gonna be the C, the row, all with C. And remember, it was C5. So then is C for the row and 5 for the column. So the column will be this one. This will be the column 5. So I'm going to mark that down with color again. So it's going to be 5 here. And then you see where they intersect. And they intersect exactly at A6. So what that means is that the byte which is represented by C5, is being transformed into the byte represented by A6. So that X box is going to do that transformation. So it's going to do the transformation that's going to go into A6. So let me use the same color. So this is 1 byte. It will be transformed into A6. Now, the only thing I have to do to now actually write down what is the byte exactly in zeros and ones is just look at what A is in this table. So A is over here. So A is the number 10 actually. So A will be 1010. Let me mark that down with some yellow. So this is going to be B here. Oops, this is the number A in this case. So it's number A. There's one here, so it's going to be 1010. So this will be equal to 1010. And then I look at the number 6, the digits in the hexadecimal, and see what that represents. If I look at my table here, it will be here 0110. So let me use again the yellow there. It's going to be this one right here. All right, so in that case, then the whole byte will be 0110. And this is the byte that is was transformed to from this byte that is right here. And that's exactly how the process is. Now, if you do it for all the bytes in the 128-bit block, so let me scroll all the way up, even before this table. So what you do is, this is the 128-bit block here. Every A0, A1 through A15, they represent bytes, and every byte is being transformed into some other byte using the X box. So it's individual transformation of bytes. Now, and that's the process of the byte transformation. So it's just looking at this table. Now, this table comes from some mathematical background, which is not part of the class, but is based on mathematical concepts called groups, or the Galois group of certain number. And of course, we're not going to discuss that, but there is a mathematical reason why the table has to be like this. In any case, the only thing you have to do at this point is just use this table. So know what that table is and how to use it to transform byte into another byte. So that's actually all for this video, and I will see you next time.